Welcome to Wickerson Studios. I'm going to show you what I'm working on. I've gotten this new catchphrase, which obviously has been talked about for decades or more, and that's additive manufacturing. And I'm going to walk you through this script, and I'm going to continue this in my kind of augmented reality, KUKA robotics series, basic geometries. What's happening here is I'm following a toolpath of a pretty interesting geometry that's about making pattern molds. And hopefully I can turn off the KUKA robot, which is a basic simulation of a drawing from Carl Singlein's, what is it called? Just a basic simple path. So you can go in and find those online on GitHub and put together a simple path through curves. And as long as you flatten your commands, and I have a little, you could just do an iteration from 0 to 1. But you could also have a faster, like a loop that plays through all of these curves. But that's the bottom script. The middle script is actually just contouring the geometries of what I made. Very simple little script, just putting it into lines and having spacing. And that's a very interesting thing as well. If I take this off the contours, let me disable that. And then just click on the contours, and you'll see what that's actually following. KUKA is following all these. The KUKA is doing its business. Everything it does is following all those curves. And what I then do is build a geometry, a parametric model of what it can follow. So I'm just going to hit pause on the robot for now, and actually maybe a reset, pull it back out of the way. And let's take a look at the geometry that's being created here. It's pretty easy. I've got two controls over it. If I take off my KUKA robot and only put on my this item, which is what I've generated, it's a nice pattern mold that allows you two variables of changing the amount. It takes a little bit of time to run, but not too long, a few seconds. I'm just sliding it back down. It might have been easier to type it in. The number of points that are random and actually jittered throughout the surface. And because I'm doing a Boolean union, it does take a little bit of time. There you go. I think it's jumping around now, playing around with points. But because it's kind of, I don't mind that it's not very optimized, and I certainly haven't optimized the robotics with the way Carl Singlein's playing with that. And then you can change the diameter of the circles as well, the radius of those, and they intersect, and you're left with a pretty simple pattern mold that you can send to a 3D printer or to a large scale printer. I did something by sliding this. Oh, I clicked my number slider and left what it was looking at. There it is. So you can see that it changes the thickness of it. And I just brought it down to 1 millimeter, I think, radius. A little slow when I'm just rotating around. So you have some effects on that. It might be best to just click your wheel, ruin your solver, change the size. You see it busted. If it goes too big and gets outside the edges, it won't Boolean union. So I'm going to throw on about 100 items. I'll throw them on at 3 diameter. And then I can go back in and hit the solver and take the solver back on and have a look at what we have here. It's still going to take a few seconds to run, and I'll walk you through the script. But basically, I build my own patterns. I can send them to print. But that's not really the sole goal, to have this nice little item that can be pattern mold into a Petrobond similar to the piece that's behind me. But you can also find the contour lines throughout that as you go. And you can also find the KUKA robotics toolpaths to make it actually run, which is kind of nice. And I just put on a basic spindle tool, I think. What was the tool? The KUKA ID tool, which is this one, the spindle. And that's it. And then you can run through all those patterns. So maybe a faster iteration would be to bring this down to 10, or like, let's bring it down to 26. That should run pretty quick. There you go. And we can upsize our diameter and see if we have a little bit of trouble with that. I actually think, I'll bring this up double. Let's see if it doesn't default. It should be fine. There you go. I just doubled the size. So you get these little circular patterns and tool paths are dropping in the spindle to mark these edges. You can see that now we have a lot less. Uh, if we take this off, you see we have less little bumps that are going to be on our pattern mold, and then of course less contours, which then have to be traced. And you can change the width of that. If I brought this down to say 2, you're going to see there's going to be many more tool paths. And the reason I was doing that is I thought, well, what if I was drilling away with a robot at a sand mold and working negative? So I hope this is making sense to some people. Like, it's trying to kind of loosely wrap my head around what am I doing, and I'm not even like playing with this in augmented reality that I could have an actual robot moving and then copy it with a physical tool. So the possibilities are pretty endless and pretty fun, and I kind of like it. And putting it all back on, pull it down, and then activate your script, and there you go. You've got, if this would play, oh, I've got to put it false. And let's hit play, and there we go. You've got 460 seconds to go through this pattern. You're going to see what if you were drilling away or milling away at a sand mold, as opposed to generating and sending to a 3D printer an object to then be pattern molded into sand. Because I have green sand and I don't have a robot, I still can use the robotic kind of intelligence to train a human, an unskilled laborer, to follow a pattern with a tool with HoloLens, and they can do it. So the possibilities in this stuff are pretty endless. I love it. Simple scripts based on simple geometries. And you can go 1, 2, 3, whatever way you want to do it. Augmented reality, KUKA robotics if you had one, and pattern molds if you had a 3D printer, depending on the size of that. So I hope you enjoyed that. That's what I'm thinking. I'm going to keep these scripts going. The scripts are pretty basic, and it's more about the conceptual direction of where I'd like to go with different places. And additive manufacturing being the key. That wouldn't it be amazing if you actually had an aluminum furnace that could generate these tool paths and actually extrude out molten aluminum, wait for its passes to cool, and then extrude aluminum on top of aluminum. I think what I'm going to start with is kind of this pattern behind me, that you've done a tool pattern, put in bronze or aluminum, and then put in respectively glass or aluminum into that, into the negative spaces. So you've got this very interesting stained glass. So I hope some people are listening to what I'm saying. I know it's a little jumbled. I do know there's a future in this, and additive manufacturing seems to be the future. Thanks very much for watching.